Well, good morning or good afternoon, whatever the case it may be. Welcome back. Today is Thursday, and we're going to finish section 7.7. And now Friday, there will be nothing posted, no assignment, and then we'll pick back up Monday. We'll jump into chapter 8. And we only do one section in chapter 8, and then we go to chapter 9, and then there'll be a chapter 8, 9 test before the final exam. Then we'll start reviewing for the final exam. Okay, yesterday, we represented complex numbers geometrically. We found the absolute value or modulus, and then we wrote complex numbers in polar form, and we did products and quotients. Now we're going to use something called de Moivre's theorem, and it's used two ways. It's used to find the power of a number, and it's used to find the nth root of a number. Okay, so hopefully print off those guided notes. Pause the video if you need to, come back, and then, like I said, we're going to go over de Moivre's theorem. From the homework here, just a couple of the evens. I'll post a whole answer sheet tomorrow after it's due, just so that you see this. Cosine 22 should be written this way, and 44, the answer should be 40 for your final answer. But make sure you put your work down to validate it. Okay, de Moivre's theorem. Z is a complex number in polar form. Z equals R cosine theta plus I sine theta. It's a complex number in polar form for any integer n. Okay, an integer. Z to that power is going to be equivalent to R to the power cosine n times the angle sine of n times the angle. Let's take a look at what that how that will show up here in a problem. Okay, use de Moivre's theorem to find each power of z. Write the answer in rectangular form. All right, so be careful here. Final directions, rectangular form. But we want to keep it in polar form to actually do the power. Okay, z is this value to the 8th power. We want to find z to the 8th. So that's what we are looking for. To do that, you take the modulus out in front, the R value, square root of 5 to the 8th power. And then since this is in radians, we're going to work in radians. And then you do cosine of 8 times the angle plus I sine of 8 times the angle. And now we're going to keep going through here, and then we got to write our answer in rectangular form. All right, well, what is square root of 5 to the 8th power? Square root of 5 to the 8th power. That's going to give us 625. 8 times pi over 4. 8 times pi over 4 is going to equal 2 pi. 8 divided by 4 is 2. So you get 2 pi plus I sine of 2 pi for that. Well, we just need to figure out what cosine of 2 pi is and sine of 2 pi is to finish this problem. Cosine of 2 pi, well, that's 360 degrees. What's the x value there? The x value there is 1. What is the y value there? It is 0. So you're left with 1 plus 0i. We can go ahead and distribute, and that just gives us 625, okay, because the 0i is just going to disappear. So that's what we're going to get for z to the 8th. Now, for part B, it says z equals 2 minus 2y. Find z to the negative 4th. As long as it's an integer, positive or negative, we can find that. Now, what we want to do is we want to convert z to polar form. So we got to find the angle, and we got to find the R value. Well, where is z at? 2 minus 2i. Right here is z. It is in quadrant 4. I'm just going to connect that for now. Whoops, not too good drawing there. Well, what is your R value? Our R value is going to be square root of 2 squared plus negative 2 squared, which is a square root of 8. I'm going to go ahead and simplify that. 2 radical 2. Our angle, our reference angle, first of all, inverse tangent, absolute value, negative 2 over 2, which is just negative 1, but we're taking the absolute value, which is 1. So inverse tangent of 1. And hopefully we know that that's 45 degrees. Since it doesn't say anything about whether I need to be in radians, I'm just going to stick with degrees. That is this reference angle. But the actual direction angle has to be 360 minus 45, 315 degrees. So now here's where we're at with z. In polar form, it is 2 square root of 2, and then cosine of 315 plus I sine of 315. Now we want to figure out what z to the negative fourth is. So that's going to be 2 square root of 2 to the negative fourth power cosine negative 4 times 315 plus I sine negative 4 times 315. All right, well, what is 2 square root of 2 to the negative 4th? That is 1 over 2 square root of 2 to the 4th. And what's that going to be? Well, we can do this without a calculator. It's not too bad. So just do 2 square root of 2 to the 4th. Well, what's 2 square root of 2 times 2 square root of 2? 2 times 2 is 4. Square root of 2 times square root of 2 is 2. That's 8. So that squared is 8. We got 4 of those. So it really becomes 8 times 8. 1 over 64. So z to the negative fourth is 1 over 64. And now cosine, what is negative 4 times 315? That's negative 1260. Plus I sine of negative 1260 degrees. I would suggest you convert that to a positive angle right now. What is cosine of negative 1260? Well, just add multiples of 360 till we get a positive angle. And it is coterminal with 180. So that is the same of cosine 180 degrees plus I sine of 180 degrees. We're still going off the directions from the previous one where we're going to write our answers in rectangular form. So now at this point, cosine of 180 degrees, that is negative 1. Plus sine of 180 degrees, which is 0. So in the end, basically distribute your 1/64. My final answer is negative 1 over 64 in rectangular form. So that is what z to the negative fourth equals. So that is how we use de Moivre's theorem to find a power of a complex number. Now the next piece of de Moivre's theorem is finding a root of a complex number. So the nth root of a complex number. Now, I don't know why they, have a W here. Typically, that's a Z. I'm just going to keep it as a Z. R is greater than 0, theta is in degrees. We get multiple answers when we do square roots, cube roots, fourth roots. So here's the deal. Z sub k is going to go from 0 to n minus 1. So if n is, we're finding the 1/4 root, or the fourth root. N would be 3. And we got to do 0 plus 360 degree k divided by n. Same thing here. Now, it looks very messy right now. When we go through one, I think it'll be a little bit easier. So theta is in radians. Replace 360 by 2 pi. But I think we're just going to do everything in radians. Or excuse me, in degrees. Makes life a little bit easier. All right, here's the actual problem. This is your actual problem. Find the 3 cube roots, or find the cube roots of 1 plus I in polar form with the argument in degrees. So we want our final answers to be in polar form. The argument is in degrees, which means the angle. Okay. And since we're taking the cube root, there's going to be 3 answers. Well, this is just the formula. I have it here just so it's easier to refer back to, so we can have it in front of us. So what first thing we need to do is we got to take this z is 1 plus I and convert it to polar form. Convert it to polar form. Well, 1 plus I is going to be in the first quadrant. Okay, right there. R, your R value, is going to be the square root of 1 squared plus 1 squared, which is going to be square root of 2. Our reference angle is going to be the inverse tangent of the absolute value of 1 over 1, or just 1. Hopefully you remember this, but it's 45 degrees. Since that is in quadrant 1, our reference angle is the same as our direction. So I don't need to do anything else. So here's what we got for z. Z is now square root of 2 times cosine of 45 degrees plus I sine of 45 degrees. We'll put that over here as well. Z equals square root of 2 cosine of 45 degrees plus I sine of 45 degrees. Since we are looking for the cube root, that means n is 3. Fourth root, n would be 4. Square root, n is 2. We are going to let k go from 0 to n minus 1, which is 2. So for our case, k is going to start at 0, and then it's going to go to 1, and then it's going to go to 2. We're going to do this 3 times because we're going to get 3 cube roots. I'm going to try and keep this on the screen for the first one. So z sub k, z sub 0, this is our first cube root. R to the 1 over n is going to be the square root of 2 to the 1/3 power. Cosine theta plus 360 degrees times k divided by n. N is 3. Our theta is our angle. It's 45 degrees. Plus, here's what's going on. You have 360 times k, which is 0, divided by 3, plus I sine of 45 plus 360 times 0 divided by 3. Square root of 2 to the 1/3 power. Well, square root of 2, the square root is the 1/2 power. So this is 2 to the 1/2 power to the 1/3 power. Well, what you do to powers here, remember you multiply power times a power. 1/2 times 1/3 is 1/6. So this is going to be 2 to the 1/6 power. And I'm just going to leave it like that. Now, what I'm left with here, this is just going to be 0. I'm just writing it out because of the formula, just so that I have it. But that's going to be 0, and that's going to be 0. So really, this just becomes 45 divided by 3. 45 divided by 3 is going to give me cosine of 15 degrees plus I sine of 15 degrees. They wanted the answer in polar form. That is our first answer. Okay, that is our first cube root. Okay, that is our first cube root. So z sub 0 equals 2 to the 1/6. Just leave that. That is fine. It'd be the sixth root if you wanted to write it out. Cosine of 15 degrees, I sine of 15 degrees. Now, here's what it means. If this is a cube root, if I took this to the third power, I would have to get back 1 plus I. I'd have to get back my original problem, okay? Now I need to find two others. I'm going to find the same thing. And I'm going to go through that process so that z sub 1 will equal, because k goes from 0 to 1 to 2. And it's going to be square root of 2 to the 1 over n, which is 3. Cosine 45 degrees plus 360 times k, but k is now 1, divided by 3, plus I sine of 45 plus 360 times 1, divided by 3. So the second one is going to be square root of 2 to the 1/3. Well, that's just going to be 2 to the 1/6. Those are always going to be the same. Cosine. All right, what's my angle going to be? 45 plus 360 divided by 3. So it's going to be 135 degrees. So my first one was 15 degrees. My second one's 135 degrees. So there's your second one. The third one, okay, there's cube roots, so there's going to be 3. K is 2, so technically it goes k equals 0, k equals 1, k equals 2. Those are how we get those 3 roots. Square root of 2 to the 1/3 power. Cosine of 45 plus 360 times 2 divided by n, which is 3, plus I sine 45 plus 360 times 2 divided by 3. And so z sub 2 equals 2 to the 1/6 cosine. All right, what do I get for this one? 45 plus 360 times 2 divided by 3. 255 plus I sine of 255. And that will be your third answer. Okay, that'll be your third answer. So we got 3 cases here: z sub 0, z sub 1, z sub 2, 3 cube roots for 1 plus I. All right, same concept. Find the 3 cube roots of 8. Well, 8 is a complex number. It is 8 plus 0i. Okay, it is a complex number. We're going to convert this to polar form. So in this case here, z equals 8 plus 0i. And if you think about this, where's that at? That is going to be on the x-axis. And so z, and what is the degree there? What is the degree? The degree is going to be 0 degrees. So I'm going to convert this to polar form. The modulus is going to be 8. That's going to be the distance from the origin to there. Cosine of 0 degrees plus I sine of 0 degrees. And in this case here, since I'm looking for the cube root, n will be 3, and then k is going to go from 0 to 1 to 2, okay, to n minus 1. Again, I got the formula here is a reference. All right, well, what's this going to look like? So I'm going to tell you there are, in the complex numbers, there are 3 cube roots of 8. And so let's find those. So for the first one, z sub 0, that is going to be 8 to the 1/3, 1 over n, cosine of the angle, which is 0, plus 360 times k, which is 0, divided by n, which is 3, plus I sine 0 degrees plus 360 times 0 divided by 3. So z sub 0 equals 8 to the 1/3, which is 2. All right, 300, this just becomes 0. This really doesn't change. Plus I sine of 0 degrees. Now, you may notice cosine of 0 is 1 and sine of 0 is 0. This would really simplify to 2. You can leave it just like this, like you have it right here. But that really simplifies to 2, which is, we know the cube root of 8 is 2. But in the complex numbers, we're also going to get 2 additional ones. All right, I'm going to pause this here, and I want you to finish it. I want you to find z sub 1, go through, use your formula, and then find z sub 2. Like I said, I'm going to pause it for a second. All right, let's just finish those up here. Hopefully you got through there. So z sub 1, start with the same thing here. You'll have 8 to the 1/3 cosine 0 plus 360 times 1 divided by 3 plus I sine of 0 plus 360 times 1 divided by 3, and that gives me 2 cosine of 120 degrees plus I sine of 120 degrees. And that will be our second answer. So in the complex plane, that is in complex numbers, that is a cube root of 8. And then the last one, z sub 2 is going to be 8 to the 1/3 cosine 0 degrees plus 360 times 2 divided by 2 plus I sine 0 plus 360 degrees divided by, or times 2. Actually, this should be divided by 3. Sorry. And z sub 2 equals 2 cosine, and what do we get there? That's 720 divided by 3, 240 plus I sine of 240. And there is our last answer. So if you've got cube root, you're going to have 3 answers. Okay. This is a application in electrical engineering. Impedance is something that comes up with electricity. And in a parallel circuit, we can calculate the impedance, which we designate z sub t, by multiplying the two polars, the two complex numbers together, and adding them and taking their quotient for that. So if you're given z sub 1 and z sub 2, we can calculate it. All right, now this is pretty messy, and I think what I'm going to do is, under the circumstances, we are not going to worry about this. We are going to skip that. It is in your book. how to do that. But we are not going to worry about it. We have enough things to worry about. And like I said, this is pretty involved. So we're going to skip over that. So cross that out. This is your homework. Okay, this is your homework. Since we crossed out that last one, cross out number 83. Don't do that. So those of you who have watched this video all the way through, you'll know not to do 83. And anybody that comes up to me and asks, or comes to the conference and asks me about number 83 or gets stuck on it, I know why. So don't tell them. Let them struggle on it. Okay, if they can just tell them, oh yeah, it's easy. And then see what they do. But all right, everybody have a great weekend. This is due Friday by 11:59 p.m. Okay, Friday by 11:59 p.m. Don't wait. Get it done today. Have a great day. We'll see you. Have a good weekend.